Hi, my name is Rick Schmitz. I started LegalThings together with Arnold in 2014. Today we're going to tell you something about live contracts. But I want you to picture this because most people are not in law here or formalizing agreement all day. So let's look at it this way. A live contract can be visualized as a law or contract that can be executed by both computers and is understandable for a human as well, without being a lawyer or judge. So we didn't get there through an ICO and a good white paper. We actually get there because we started a company doing actually something like this starting in 2012. When in 2012 a new law became effective called the Flex BV, it became possible to create companies in the Netherlands without a long waiting term and a big capital to start a company like an LLC. It became really easy to create one. So we thought, okay, why are we not digitizing this? So let's digitize all steps to create a deed of incorporation by checking all the steps towards this and triggering it for the notary to be involved, to the founders being involved, and other guys being involved in the process, so that it becomes much faster than before and obviously much cheaper than before. That's the company I started in 2012 called Firm24. But from there we moved on because we saw that this was much more usable in basically every type of company where paper is involved, moving through trail with checks and balances and tasks moving around. So that's why we created LegalThings. LegalThings focused on signing and creating the contracts on paper, automated on paper. But then we pivoted a little, putting those rules, breaking those agreements up in rule sets into finite state machines. Then we started to experiment with the Bitcoin blockchain. So there was something about the music industry. We introduced it in Cloud9, you probably know it. So they're a user of our product, but they're signing contracts, and after they sign it, it gets hashed and it will be stored with a proof of existence so that everybody knows, so also Mr. Hartwell knows that the gig has been signed and that's actually the agreement you agreed upon with the other party. But I don't think Cloud9 even knows that it's there because they think they just see a signature on a piece of paper, right? But we have the immutable evidence that it actually happened. All right, so we moved on and we created a way to make a law actually being executed into the blockchain. And we presented that at the Blockathon issued by the Ministry of Justice to impound a car. This is a huge law. Like, okay, a guy gets holed up in his car. He had cocaine in his trunk. Obviously, it's the Netherlands, and then it needs to move around through at least 14 departments, the truck picking up the car, Forensic Institute being involved, and the entire process was formalized into a live contract, a finite state machine. So that's what it actually is. It's an agreement, like you normally have. An agreement you normally have on paper, you put in a drawer, left to be forgotten. But we consider a contract something that is alive. Every clause, every rule within that contract or law is something you can interact with. And every interaction, we store that in a mutable way into a decentralized storage and on blockchain. So the goals when we were creating LegalThings was actually distributing power. So without having an entire, or having a small elite group pulling all the strings, we want to distribute the power among the people. So empowering self-reliance, reducing the workload and friction, and mitigating fraud were our main goals. So let's move to the first one, empowering self-reliance. To make this happen, we actually need the people to understand the rules. We need to give them access to information without having to rely on a government. And we need them to have the power to execute. So somebody can decide if he wants to buy back his car or he wants to violate a clause in an employment contract. This is something you can do yourself without having to rely on a lawyer. Okay, reducing friction. I can explain that the best looking at the law of McKelvey. Communication is very inefficient when you're in a big organization. And I'm going to show you that. If you're with 2 people, you have a communication line, just 1. If you're with 3 people, you have 3 lines. But moving that to, let's say, 13 people would give you 78 lines of communication. So it becomes impossible to answer a simple question. So why not creating an efficient system? Well, there's a reason for that. And I'm going to explain you.
Why does bureaucracy exist? Well, fill in your W17 L3SS continuation forms now to watch the rest of the video. Really, the point of bureaucracy is accountability and organisational functionality, or the overt point of it is. I don't think I will be astounding anyone to say that I do believe some elements of bureaucracy, or even entire bureaucracies, are there to line pockets and look busy. But bureaucracy, in theory, allows the outsider, whether that be the public, the taxman or regulators, to see how decisions are made and who is responsible for those decisions. It also allows the people at the top to see who beneath them is doing what and where problems lie. It's essential in monitoring activity through reporting and ensuring that a system is rational and that it's not based on traditions or favoritism or the whims of a Caligula-like figure who, like that emperor, will end up being torn apart by his Praetorian Guard, to favour efficiency and output over cronyism or self-interest. Bureaucracy has been key in curtailing things like institutionalised racism, eliminating inefficiencies and streamlining processes, and issuing fairer systems for the allocation of funds or services, all because it presents inescapable checks and balances.
Exactly. We cannot create an efficient system because we need an inefficient system, because we need bureaucracy. Because we need people jumping through hoops to get stuff done, to get, let's say, a permission to build or some other permission. Because when you don't have that, you don't have a trail of proof of work, so that actually something is not done by changing the system. Let's say in Somalia, it's probably pretty easy to get a permit to build because the 3 guys at the top can just give it to you when you give money to them. But that will give rise to fraud. We have in the Netherlands, it's like really, really hard and a 20-week process to build a new house. So we have a lot of bureaucracy, but we don't have a lot of fraud because it's really, really, really hard to like bribe a lot of guys to get that building permit. So bureaucracy times fraud is a constant, so we actually need it. So how can we create an efficient system while mitigating fraud? That's where Arnold comes in.
So, does this work? This, I need a thingy para as well. Now it should.
Great, so this is going to be a little bit of a tech deep dive. We're going to talk about our solution. So, a number of things we want to do. We do not want to give a certain party, even if it's the government, too much power. We want to distribute the power. So what do we need for that? We need a decentralized storage of data. We need things like encryption, because we want to keep private stuff private. We need digital signing. And we're going to use the blockchain, something called Ricardian Contracts, and a finite state machine. Let's go to the first. There we go. So what happens if you create a central system and say, okay, you're responsible for storing the data? Well, then it becomes pretty easy to manipulate the data. And even if you put in some kind of permission system and say, okay, this party is actually going to be trusted and don't really have a reason to change the data, it's still dangerous to put that much power, that much trust into one party. There are unconventional ways to convince somebody in that organization to simply change the data, to simply do a data update. Let's say I bribe somebody, or maybe I'm going to kidnap your daughter and say, okay, you have to remove that record that 100 kilo of drugs was impounded. We don't want anybody to have that kind of power. We're going to solve that with decentralizing the storage. Well, decentralized storage is nothing really new. I've put a picture of the Pirate Bay there. We all know BitTorrent, and we can see some properties of that. First of all, the data is split up into small chunks, and it's spread across many systems. So removing data from one system really is pointless. Multiple systems have the copy of the same data. This is really the same point, actually. And downloading can be done peer-to-peer. So there's not really a central point I can disturb or I can hack to prevent people from getting that data. And the most important part, there's not a single owner of the data. The data is out there and we all own it. So how do we do it? Because we have private data. If somebody gets arrested, maybe it's guilty, maybe it's innocent, but we don't want to announce that to the world. We want to keep that private. On the other hand, the different parties have to work with data, so they need to have that information. Well, we use encryption for that. But encryption alone is not enough. We use AES 265. Well, that's pretty safe today, but you never know what's going to happen. Every encryption can be broken. So another thing that we do is we use data striping. We take the first bit of each byte and combine that to form a new message. You can compare that to actually shredding some paper. These messages, they are just nonsense. If you do not know the right order in which to place them to recreate the original message, you don't even have anything to decrypt. Okay, so the blockchain. Probably everybody knows what the blockchain is and how it works. I'm going to go through this really fast. We have a block with some data. There's the numbers. We're going to hash it. Hashing is a simple function that gives a result. Important part is it is one way. So for this case, we have 12, but we cannot derive that the input data was 3 and 9. It could be 6 and 6. And we're going to take that hash and add it to the block, which forms the first part of the new block. We can continue doing this. For the second block, we create a hash, stick the rest on it, etc., and we get a well-known jigsaw puzzle. Well, this is really the basic of the basics of the blockchain, and we incorporate this principle. Another thing that we want to do is signing. Everybody is probably knows RSA encryption. So we take plain text. We've got a public key. We encrypt the data, and you'll get an encrypted message. Then you have your private key, and you get your plain text message back. So this is done for HTTPS and those sort of things. But we can actually switch the private and the public key. So now we have the plain text message, we encrypt it, and we get the ciphertext. We're gonna store that encrypted message with the normal, the original message, the plain text message. What we can now do is anybody can use the public key to decrypt that ciphertext and see that it matches the original message. So they can be sure that my private key was used to sign that message. Taking this all together, we're getting to a concept called Ricardian Contracts. So we have our original document, our agreement. We're going to sign that using digital signatures, P2P, RSA. We're taking a hash from that, and that actually forms the first block of a small blockchain. Then all the events that are related to that contract are added, are appended in the storage. So we can see what happened, and we can see that it happened in that order. So there are a couple of ways we can formalize an agreement. Traditionally, we've used paper contracts, which have a natural language. Well, the problem with the natural language is it's ambiguous. Words can have double meanings. Punctuation can basically change the whole meaning of the sentence. And that's why lawyers, lawmakers invented the legal lingo. It works, but it basically means that the rest of us no longer understands what's actually in the contracts. A lawyer needs to come and explain it to us. We think that's a problem. Well, smart contracts, they have a benefit that they're understandable by computers. They can take the rules and nobody really needs to know them because they can just be executed. But by that, we're giving control to the machines. If they're saying, okay, it's correct, then it's correct. And if they're saying it's wrong, it's wrong. Maybe a developer can look at the code and understand it, but basically it just does what it does. How can you say, okay, this is not what we agree upon if it's actually there in the code? So our solution to this problem is to formalize an agreement as a finite state machine. A finite state machine is really an old concept in the Automa, which predates actually computing and Turing-complete languages as we know them now. It has some advantages. It's understandable for both humans and computers. We can visualize it, and we're going to see that in a bit, as simple flowcharts. Also, the computational power is far less than what you have with Turing-complete programming languages. That means that you cannot make the same errors what you see now with the parity bugs and things like that. Let's have a look. So let's compare smart contracts with live contracts. One of the things with a smart contract is that there has to be consensus throughout the networks because all the nodes go and execute the smart contract codes. But that's a problem. That means that there has to be some data, some indisputable facts that are put on the blockchain which the smart contract operates on. But who is going to put that data on there, and who's going to determine that these are actually the indisputable facts? What we see now as a solution is that people rely on something called oracles. The oracles put the data on there. But that makes the oracle in itself the trusted third party, and that's really the thing that we're trying to solve with the blockchain. We want to move away from trusted third parties, not create new trusted third parties. With live contracts, we're taking the opposite approach. We're saying, okay, you can only ever put the data on as yourself. So if I'm saying, okay, the price of the Bitcoin today was $12,000, I go and sign that message and I'm going to store it. And that's my vision. That's something I've said. And I'm going to ask other people to sign it, to agree with me, to acknowledge that. At that point, I can say, okay, I agree, you agree, and other people may agree as well. But there's never a universal truth. And that's something really, really important. So let's go to actually go to a simple example of formalizing an agreement. So we have Jake. Jake gets a new side job. He's going to mow the lawn of his Uncle Mike. He gets paid $10. There's some conditions about it. The grass have to be 2 inches, don't damage the lawn, or, of course, the very nice garden gnomes. There are 20 gnomes. If he's going to damage them, they're going to be, it's going to cost him $30, frequency, etc. So let's put it in a paper contract. Here you can see an example of, well, a little bit illegal lingo, but it's still quite understandable. The problem is there's a small mistake with big consequences. I'm going to give you a little time to read it and to actually find it. So who thinks he spotted it? Nobody? Okay, then I'm gonna show it to you. There's a comma here. And we see Jake and Mike agree that Jake will mow Mike's lawn and get paid $10 unless Jake damages the lawn. Well, putting this comma here with the unless means that the rest of the condition applies to the whole sentence before. So if Jake damages the lawn, the whole contract becomes void. Well, that's not what they wanted to agree, but if it would come to a lawyer, that's what the lawyer would decide, because that's what's on paper. And you think maybe, this is hypothetical, but we've taken this case from an actual law case in Canada, where a telecom company lost $1 million because the contract was ended after 1 year instead of 5. So let's take a look at how we would write this as a smart contract. We can see this is a pretty simple smart contract. It's still pretty readable for anybody who writes Solidity, but it's pretty easy to sneak something in here. Maybe somebody who's a developer can actually spot that. So Uncle Mike really has a big advantage, and he can bomb the whole contract. So we see that. Now, I don't really have a pointer, I think. Do I have a pointer? Yeah, I do. So we can see that he put some sneaky thing in here. He says, name a function set bonus, which the owner, Uncle Mike, can set, and he can set it to any number. And then we say the contract is fair if the bonus is greater than 0. Well, here we've got a modifier, must be fair, and basically, if anybody wants to interact with the contract, we say the contract must be fair. But Mike can simply set the bonus to 0 and make the contract not fair and basically void this whole contract if he wants to. So, well, if you would just scan over this as you would see, okay, this is a normal contract, everything is well, but you really have to scrutinize it like lawyers do now over paper contracts to spot this kind of exploits. And that's a big problem with smart contracts. It's really easy to put in intentional or unintentional exploits. Another problem with smart contracts is that it's self-enforcing. And self-enforcing sounds really nice, but there's not much way you can self-enforce something. Self-enforcing means you cannot take your smart contract and go to a judge and say, okay, you know, this was in the contract and I didn't mean it. No, it's self-enforcing. So anybody can just walk away from the contract. Well, to solve that, basically, you have to put in a deposit. In this case, we say, okay, we want to make sure that Mike is going to pay when the lawn is mowed. So when he's signed, he's going to put in 2 Ether, and that's going to cover the cost of mowing the lawn for 2 years. Also, Jake, well, he can damage the gnomes, and then he needs to pay for it. Well, we want to make sure that he doesn't just walk away from the contract. So, you know what we're going to do? We're going to put a 2 Ether deposit as well in for Jake when he signs it. Well, you can see if this is a contract about getting paid $10 per week, putting in 2 Ethers, like $800. That's not really reasonable. Take, for example, a normal employment contract where you've got clauses like an NDA, and if you break that, you have to pay $10,000 per occurrence. There's no way you can actually do that by asking a deposit. So let's take a look at our solution, live contracts. We're putting this in a finite state machine, and a finite state machine can simply be seen as a flow chart. We've got a state, the lawn should be mowed. Then here we've got Jake. He's going to perform an action, mow the lawn, and we're going to go to get to a new next state. Now it needs to be checked, and who needs to check it? It's Uncle Mike. There's some conditions here. And he can say, okay, I'm going to disapprove it, or I can approve it. If he's going to approve it, now Jake should be paid. He pays it. We're going to wait a week, and we're going to come back. So we've digitized this process in such a way that it's pretty easy to understand what's going on. We can show this to Jake, and he can say, okay, this looks fair. We can. He doesn't need a lawyer for this, but this is also something that is really easy for a computer to understand. They can understand these conditions, it can understand these transitions, and understand the states. So this is the so-called happy flow. Lawn needs to be mowed, checked, wait, blah, blah, blah. That's all fine, but what happened if the work gets disapproved? Well, we see that here. There's going to be a complaint, and it's up to Mike to state the complaint. He's including some pictures, and that gets actually logged and stored on the blockchain in an immutable way. Well, then it's up to Jake to say, okay, I agree with that. Well, then it's done. No lawyers have to be involved. It's damaged. Jake says, it's fine, I agree, and I'm going to pay for it. Or I can say, okay, now I'm disputing this, I didn't do this. We're going to give Mike the option to take a look at the answer that Jake has given and withdraw the complaint, or we can say, no, you know what, and we're going to ask your father, because we disagree. I'm sure that you've done it. So for the father, usually he needs to go to Jake and go to Mike to ask about, okay, what's the story? Can you give me some proof, etc., etc. That was all after the fact. But now, during the process, actually, all the information got logged, and the arbitration just needs to see, hey, what's in there? What has been stored? So we reduced the whole problem of fact-finding after a dispute has arrived. And fact-finding, that's actually a large part of the whole litigation process. So, I don't think we have really time for a demo. So if you want to, this is not a concept, this is actually a working product. And if you want to try it yourself, go to livecontracts.io. There's a button demo there, and see how it works. Cool. Questions?
That's really great. Thanks a lot for the insightful presentation. Any questions?
How does the legal system in save this. So if I'm going to establish a BV with your live contract, will that accept it?
Yeah, so what we're doing now is we've got a hybrid system where you've got the live contract as a finite state machine, all the data, and that's actually what the system uses. And we're generating from that a paper contract because, well, the legal system isn't that far from just accepting the pictures presented, the flowchart presented from the system. But we're actually getting to a case, if you take the impoundment, for instance, where the government is actually accepting and following these finite state machines and doesn't really need the paper to just look at their own UI and see, okay, this has happened and that's correct.
Okay, so I still need, so with the generator paper contract, I still have to go to a notary to follow some procedure to really establish the B-way.
Well, so actually, a notary is an important part in our system for providing identity. But the way the work the notary actually has to do is far less and far easier. You simply have to go by the notary and show up and say, okay, this is me, and you're going to be identified. The whole process around it and how that's stored, that's within the system. Is that? I feel that.
But then a follow-up question is there a notary that's actually using this system?
Yes. There are 30 notaries across all of the Netherlands that are using this system. If you want to do an incorporation, you can actually use Firm 24, which is built upon LegalThings, and go through the digital process, and you simply have to show up with a notary, which is gonna stamp you and gonna press on the button. Cool.
One final question before we wrap things up. In the back of the room.
I'm studying law, and I'm considering writing my thesis about blockchain and smart contracts. And I did a little research on LegalThings, and I came across your ICO. Could you tell me more about that?
Yeah, so we're doing a token sale, and we're doing a so-called a TAL solution. So token as a license. We think this is going to be the new, actually a new way everybody's going to license their product if it concerns a transferable license. At this moment, if you buy a box for Word or for Windows, you get that nice little sticker with the emblem on it. Okay, that's really easy to sell to somebody else, because how do you know that that person isn't really running a copy of that software still himself? And also, if you want to trade, you have to actually physically meet. You cannot do that over the internet. You cannot really say, okay, I'm going to go and put it on Marktplaats and buy that license. So we're doing the token as a license principle, and in that way licensing our software.
All right. Arnold, thank
Yeah.
you very much. And with that, we get to the end of the presentation of tonight. The bar is open. Again, we would like to close the door at 9:30, and then the meetup really ends. The next meetup is scheduled for February 22nd. If you feel like you know or you are a great speaker for one of the next meetups, you have a practical case running on blockchain, please get in touch with me to discuss the possibilities. Thanks again, everyone, for being here and for all your questions and interactions. Now, before we leave the room, there's a very important thing that I should not forget. And that's thank you, speakers. Here's a nice little drink for you.
Thank you.
Arnold, thank you very much. Thank you very much. And there's drinks for you as well at the bar. Again, thanks. See you next time.
Wacht, die harde, dat is leuk.